Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion for Mains 2023, most important topics for science and technology. Now, before we jump into the agenda of the day, I have a small update for all the viewers and aspirants. I received a message from one of the aspirants who asked, Sir, when the series will end? I would say we have another couple of sessions left, although I gave you a tentative date of August 31st. But again, I think in one or two sessions, we'll wind up this particular series because we are left out with two very important topics. One is space tech, space related developments. Another one is a mini topic for defense related developments. Today, we are going to enter into the domain of space related activities in India. And you do understand this is one of the most important topics for Mains 2023. There are no prizes for guessing here because we have had great success with Chandrayaan 3, and 2023 is going to be a landmark year for us. We are going to divide this discussion of space technology in two sessions. Today, we'll talk about India's achievement in space development, and we'll talk about some of the important missions that we have completed till now. We'll discuss about Chandrayaan 3 and some other missions. And in the next session, we'll talk about some other themes which are connected with space related development in India. All right. So without any delay, let us begin today's session of Space Tech 1. But before that, there is a small announcement for all the aspirants. This is going to be one of the last batches available for 2024. September morning batch is starting from 11th. There would be again an evening batch as well. I have to tell you that. But this is going to be the morning batch at 8 a.m. P2I batch. It is available in all three formats. It is available in English as well. The most comprehensive program where prelims, mains, interview, all preparation is going on together. Just visit our website www.studyiq.com. You'll get all the information there. Enroll. If you've already enrolled, I'm quite sure you are looking at the classes, and the aspirant asks, sir, there is a lot of delay because the exam is coming on September 15. The mains exam is there. Yes, but because of some other commitments as well, some delay, and you do understand there have been too many holidays. Yes, Raksha Bandhan, etc., etc. Because of that, some delay, but we'll wind the session very quickly. But do visit studyiq.com to get all the details of our programs. All right. Right. Let's begin our discussion of space related development in India. Now, in this session, in the first session, we will talk about India's space journey or India's voyage with respect to space related activities. We'll start from 1950s and we'll reach till 2023. We'll talk about some of the important missions that we have already achieved. And in the next session, we'll talk about some other peripheral topics which are connected with space itself. Again, very, very important. Now, when we look at India's space journey, it began even before independence. Again, there was no specific organization or a mission or institution which led these ideas, but space-related research and space-related developments, we have seen contribution towards those by some of the renowned scientists like Sir C.V. Raman, Meghnad Saha. They have contributed immensely from a theoretical perspective, yes. However, a major breakthrough was achieved with respect to space-related activity in India after independence. Initially, all space-related R&D was put up under the Department of Atomic Energy, which was established due to efforts of Homi Jahangir Bhabha, and again, the political executive at that time. However, from the Department of Atomic Energy, specific activities connected to space were separated by Jawaharlal Nehru. In 1962, a specific committee was set up which is called INCOSPAR, Indian National Committee for Space Research, INCOSPAR. This was chaired by Vikram Sarabhai. So, although we say that all these space-related activities, this started with INCOSPAR, which later on turned into ISRO. But even before that, there have been so many contributions towards space-related developments. In fact, if you want a more larger perspective, we can talk about so many contributions from the ancient and medieval texts towards astronomy and astronomy-based studies. We can give example of Aryabhatta, right? Aryabhatta, Brahmagupta. Many ideas have come where without sophisticated tools, without sophisticated equipments, they had calculated the celestial distance, isn't it? So India has had a great tradition towards space-related studies and space-related activities, which continued even after independence. But the beginning was with INCOSPAR, meaning from the Department of Atomic Energy, specific committee was created for all the space related activities and space research. And this INCOSPAR, later on, it turned into ISRO. It became ISRO. What we know ISRO, Indian Space Research Organization today. Its origin was a committee which was called INCOSPAR. And during this period itself, under the aegis of INCOSPAR, the TERLS was set up, Tumba Equatorial Rocket Launching Station. Now, you must have seen so many images. In fact, I'll show you one of the images where a scientist and the ISRO people or the INCOSPAR people, they were taking rocket equipments on a cycle. And after the Chandrayaan-3 launch, we saw those passionate images about how India has taken a leap forward by carrying first rocket equipments on a cycle. Today we have reached moon, and that image is of a sounding rocket itself, initial rocket launched from Tumba. And you need to understand that India today, if you look at the ISRO facilities, there are two important ISRO facilities. There is one in Tumba. Tumba comes in Kerala. This is the peninsular India map. This is easier to draw, that's why I just draw the peninsular India map. Tumba is in Kerala. This is the first rocket launching station of India. Why was it created in Tumba? Because the magnetic equator, it passes very close to Tumba, and Tumba is in Kerala. Please remember, it's not in Tamil Nadu. Apart from this, we also have a small island here off the coast of Andhra. Now this island is called Sriharikota. Sriharikota. Now the Sriharikota, this small island, this is our launching station. What launching station? All the satellite launch station, all the satellite launches are done from Sriharikota. From here, we normally launch the sounding rockets. We normally launch the sounding rockets. Now, what is the meaning of sounding rocket? Sounding rockets are the initial rockets. Again, under that, the most important rocket that we have developed is Rohini. We have developed Rohini Mark 1, Mark 2, Mark 3 versions. Sounding rockets are the rockets which are released basically for study of upper atmosphere. That is why the term sounding. In naval terminology, sounding basically means measurement. So sounding rockets launched from Tumba Equatorial Rocket Launching Station. From Sriharikota, we have two launch pads here. We have two launch pads. Recently, we have developed one more. There are two launch pads from which all the space missions go. All right. All the space missions, that is PSLV, GSLV, other space missions, they are launched from Sriharikota. Now, just off the record, not connected to space, connected to defense, we also have a small island here. This is called as Wheeler Island off the coast of Odisha. The Wheeler Island, it has been renamed to Dr. APJ Abdul Kalam Island. Now, this is a place from where we carry out our missile testing. All right, it's not exactly rocket or other launching station, but it is a missile testing facility at the Wheeler Island. So this we have developed. Now, apart from this, if we look at our own journey from INCOSPAR to ISRO, and from that time we have not looked behind. It has always been a trajectory which has been upwards. Of course, there have been some issues. There have been I can say some step backs, but we have gone always in a positive direction. Yes, I would say that not all of our missions have been successful. Yes, some PSLV launches have been unsuccessful. Some GSLV launches have been unsuccessful, but that is all a part of learning. And we can say that we have grown leaps and bounds since 1970s. Aryabhata was one of the first satellites that we launched in collaboration with Russia. Later on, Indo-Russia manned mission was sent in 1984. Rakesh Sharma traveled through the Soyuz capsule of USSR, and he became the first man from India to travel to space. Later on, we developed advanced launch vehicles. Initially, in 1987, we developed the augmented satellite launch vehicle. We enhanced its capacity and developed PSLV, the Polar Satellite Launch Vehicle, in 1994. Now, Polar Satellite Launch Vehicle, this was our pioneer launch vehicle, the most successful launch vehicle till now. In it, we have carried out, or we have developed different kind of variants. Yes, PSLV does not use any cryogenic upper stage. It only uses solid motor and liquid engine, the Vikas engine. PSLV XL can send satellites up to the geosynchronous orbit as well. It's a misnomer. Everybody thinks that polar satellite means I can only send it to polar orbit. No. Polar satellite launch vehicle can send it to polar orbit, can even send it to geosynchronous orbit, which is 36,000 kilometers height from Earth. Then in 2007, we launched the initial GSLV Mark 1, and GSLV, it started our journey of the cryogenic upper stage. Now, if we divide this particular phase, we'll understand that ISRO has been really successful in developing space and space related activities. Initially, we started with R&D, little bit of experimentation, but today we talk about applications. And please remember, whatever ISRO does it for these things. Ultimately, it has to help man and the society to solve their real problems. Now, ISRO's motto is that we must be second to none in application of advanced technologies to real problems of man and society. And that is why many applications that we have developed through ISRO, they are responsible for socio-economic development, socio-economic security. It works towards sustainable development in India. The satellite and its services, they help us in disaster risk reduction. Satellite and space related equipment, they help us in better governance and human resource development. That is why talk of any kind of launches that ISRO has made. We have launched Cartosat, ResourceSat, InSat, the navigation satellites. What is the use of those? The use of that is ultimately to Indian society and Indian citizenry. Now, if we look at our journey has been quite tumultuous. Yes, it has been of hardship, but again, it has been a trajectory of growth. I told you we began in a modest way in 1960s, 1970s. That was the first initiation phase where INCOSPAR and later on ISRO, they created a vision. And what was our vision? That we want to learn, we want to experiment. Now, this was one of the images of the rockets where a person is carrying a rocket equipment on cycle. From here, we have reached moon today. So initially, we started with learning, we started with R&D, and we relied mostly on international collaboration, international cooperation. And this part in 1960s and 1970s, we mostly collaborated with USSR. And at that time, US versus USSR race was also going on for space. And we sided or swayed a little towards USSR. After that, in 1980s, we started our own journey of experimental missions. We started to develop our own sounding rockets, learn to launch our own sounding rockets. Slowly and steadily, we started to develop our own satellite launch vehicles, initially augmented. Even before that, there was a normal satellite launch vehicle whose capability and capacity were less, but we slowly and steadily developed the augmented satellite launch vehicle, polar satellite launch vehicle, and built different kinds of prototypes. And then we were now ready to jump. We became operational, and now we started operational missions. Now, initially, we mostly focused on national services, and that is why you see any of the launches that ISRO did from 1990s to, I can give you example, till 2002, 2003, till the Antrix Corporation came. It was though established in 1999, but again, operations started a little after beginning of 21st century. So for almost 10 to 15 years, what ISRO did from 1990 to 2000s was launch more and more missions which will give national services. What kind of services? I focused on weather forecasting, right? Weather-based data. I focused on ResourceSat. I focused on the Cartosat, studying the upper atmosphere. All these things. Ultimately, to provide services to the nation. We specifically launched education-based satellite, remote sensing-based satellite, resource-based satellite. So such things where we focus on national services because we now became operational. However, in the 21st century, now we were ready to take a much higher flight. From an operational phase, now we have gone into the expansion phase. Now, ISRO stands shoulder to shoulder with the other organizations. There is heavy collaboration between NASA and ISRO, NASA and JAXA, NASA and European Space Agency. So we expanded our global footprint. We brought some expansion-based policies, and now my focus was not just on national services. Of course, national services will be there, but along with national services, now I was able to serve even the international clients. There are so many examples. I think in 2017, India created one of the biggest records where a top one particular launch vehicle, we sent 104 satellites from different countries. We had clients from France, we had clients from least developed countries, from the developing nations. Most of the satellites were foreign satellites. We sent them. So now the focus was on developing and expanding our wings and serving not just India, but serving entire humanity, serving the world itself. And that is why we are slowly and steadily moving towards that client based model where we want business from others, because there are very few organizations who are able to do this, right? NASA is one, the European Space Agency is one, yes. There is JAXA, the Japanese agency. Then there is a French agency, CNES, that is also quite advanced. USSR agency is there. Right now it is the Russian space agency, Roscosmos is there. ISRO comes or stands right along with them. It's a great journey. It's a great journey of, I would say, learning, hardship, but a lot of positivity. Many people ridiculed us, right? Many people ridiculed India, that India does not have a chance to even stand as a democracy. But we are not just a strong and a thriving democracy. We have achieved great milestones in space related activities and space related development. So when you're writing an answer where a question is asked, what has been India's odyssey towards space related activities? Now this is a way to, I would say, present it in a very coordinated manner, because this is a ready-made content which is given to you by ISRO itself. How we started through initiation, then experimentation, then operationalization, then now we are in the expansion phase. 21st century is our century. What have we achieved? We have achieved these things. Till now, ISRO has achieved 124 spacecraft-based missions. 93 launch missions have been conducted successfully. Student satellites, about 15 have been launched by ISRO. We also have conducted 2 re-entry missions. Re-entry means we launch a launch vehicle, and then we make that re-enter into our atmosphere, and under that we are also developing something called as RLV, reusable launch vehicle, and for that we have already demonstrated the basic technology that we need. Yes, it is in development phase. We have launched 431 foreign satellites. 431 foreign satellites. Apart from that, we have realized 3 satellites which are developed by Indian private players. Now this is a little nascent, because slowly and steadily in the expansion phase from the government control, now I want private sector to be involved more and more in space related activities. So this is our journey of the space voyage or space related developments. Now apart from this, what have we achieved? Some of the landmark missions that we have completed, or some of the landmark that I can think of. First is our development of the liquid based engine, that is the Vikas engine, which we indigenously developed in 1970, and this was of course used in ASLV, augmented satellite launch vehicle, later on in PSLV as well. Now PSLV XL is the most advanced version of polar satellite launch vehicle, which has a capability to send about 1750 kg to the low Earth orbit, and it has a capacity of about 1400 kg which can be sent to GSLV. And PSLV has been a workhorse of ISRO. Most of the successful projects that we have sent, for instance, Chandrayaan 1 PSLV, the Mars mission, again PSLV, most of the Navik missions, that is IRNSS missions, again from PSLV. It has been a workhorse for ISRO. Apart from that, we developed the technology and testing needed for cryogenic upper stage in 2007 with the beginning of GSLV. Now this was very interesting, because you are thinking, sir, we developed one of the engines indigenously, Vikas engine, way back in 1970, and why it took time for us to develop the cryogenic upper stage? Cryogenic upper stage, it is quite complicated. Cryogenics is connected with science at very low temperatures, approximately minus 150 degree Celsius temperatures. So initially we were relying more and more on USSR, but you do understand If you look at USSR and its foreign policy from 1991 to approximately 2000 till Vladimir Putin became its president. Now, this phase was a phase of US or Atlanticism in Russia's foreign policy. The president this time was Boris Yeltsin, and his foreign policies were such that they were more aligned with United States of America. Later on, after Boris Yeltsin, Vladimir Putin has come from 2000, and more or less he has remained in power, barring a 4-year period where he was prime minister, right? So from this time, we have had again good relations with Russia, but during this particular phase, India was supposed to receive cryogenic upper stage technology transfer from Russia, which did not happen. So we developed our own indigenous cryogenic upper stage, and that is what we use in GSLV Mark III. And successful testing of Mark III was conducted in 2014. And using these launch vehicles, PSLV, GSLV, the Vikas engine, the cryogenic upper stage, we have launched successful missions. One of the most important missions was Navik. It began in 2013. We completed the constellation of Navik, 7 satellites in 2016. By 2016, India has a constellation of 7 satellites in the geo orbit. Some of them are in geostationary orbit, some of them are in geosynchronous orbit, and these will provide you the location-based services. Location services. That means India is one of few countries in the world which have their own positioning system. Of course, there is GPS, which is United States of America based. There is GLONASS from USSR. There is Beidou, which China has developed. There is Navik. Navik's earlier name was IRNSS, Indian Regional Navigation Satellite System, but it has been renamed to Navik. Navik is our own local GPS, and this gives you services only over India and an extended boundary or extended area of 1,500 square kilometers beyond India's borders or India's territories. That means it can provide services to India and India's neighbors. Navik, a very, very successful mission. Right now, I'm quite sure most of you people in your phones, you will be getting an option. I don't have it because I have an old phone, almost 3-year-old phone I have. So if you have bought a new phone, which is 5G phone, there you will have an option of using either GPS or Navik. Do you have it? I'm quite sure many would have that. It's a great achievement for India. Now, apart from that, we also launched the Mars Orbiter mission in 2014. This was successful. This was a huge, huge success. How did we send it? Again, through PSLV only. Mars Orbiter mission was one such mission which gave us immense national pride, because India was first country which reached Mars in its first attempt. Although Mars Orbiter mission is now complete, the orbiter has sent a lot of information about Mars's upper atmosphere and connected data to it. Last year, the connection or the connectivity with the orbiter of Mars, it has been lost, and the mission is completed. Mission has been dubbed as completed because the connectivity is lost already. And very recently, we launched Chandrayaan 3. Now, this has been one of the landmark projects or landmark missions that we have launched. Again, this has given us immense national pride again. India is the only country in the entire world to demonstrate soft landing of its spacecraft on Moon's south pole. Yes, there are many people who have reached Moon. They have sent astronauts to Moon, yes, but there is only one country which has reached South Pole successfully, and that is India. A great achievement. And we saw that on August 23rd, 2023. ISRO said that I reached my destination. Chandrayaan 3 has successfully soft landed on Moon. And in fact, the moment that we are discussing this, even now, the Chandrayaan 3 lander as well as the rover, it is sending a lot of information to the centers, the connectivity centers or the satellite centers. All right. Now, what was this Chandrayaan 3? To understand this, we need to know it has a continuing mission. One of the first missions to Moon or to Chandra was Chandrayaan 1, which we sent in 2008 to the PSLV. Now, this was the first mission. Let me just give you an overview. Please remember, in this Chandrayaan 1, Chandrayaan 2, and Chandrayaan 3, there are some differences. Chandrayaan 1, we launched it in 2008. The mission ran for almost 300 days from 2008 to 2009, and this was sent through PSLV, and we only sent an orbiter. Now, what is the meaning of orbiter? Which orbits moon. Now, this orbiter also sent a lot of information about the moon and basically moon's composition. Yes. Later on in 2019, we sent Chandrayaan 2, and this time we sent it through GSLV. And this time in 2019, what we did was we sent an orbiter, we also sent a lander, and we sent a rover. But what happened, unfortunately, in 2019 was that the mission for the orbiter was success. This was success, but the lander and rover, they crashed. They crashed. And you must have seen those emotional images where Prime Minister Narendra Modi was consoling at that time ISRO chairman K. Sivan, because the lander rover had crashed. And now finally in 2023, what have we achieved? It was a follow-up mission in 2023. This was a follow-up for the 2023 mission. We are using the same orbiter. That means same orbiter connection has been made. Along with it, we have followed it up with lander and the rover. Now, this time it has been a grand success. This time it has been a success. Let me write it with blue here. This time it has been a grand success. Great. So what happened? What happened exactly? Let's try to understand. I told you Chandrayaan 1 only orbiter was sent. Chandrayaan 2 orbiter was successful, but the lander Vikram and the rover Pragyan, it was same name that was given to them. They crashed. And this time we followed it up. Chandrayaan 3 is a follow-up mission to Chandrayaan 2, which was launched in 2019, where we wanted to demonstrate end-to-end capability. Now, what is our objective of Chandrayaan 3? It is a 14-day mission. It is a 14-day mission where I want to demonstrate safe and soft landing on the lunar surface. I want to demonstrate rover roving on the moon, and I want to conduct in situ scientific experiments using the lander and rover payloads that I have sent. Now, I have sent certain science-based payloads with the lander. And this time, for the safety, the lander was given additional fuel, lander was given additional solar panels. Along with it, 7 scientific payloads have been sent. 7 scientific payloads. First one is Ramba, radio anatomy of moon-bound hypersensitive ionosphere or atmosphere. CHEST, Chandra surface thermophysical experiment. ILSA, now recently ILSA has sent some very interesting insights regarding moon instrument for lunar seismic activity. Now ILSA has sent some very good information about the previous seismic activity in moon. Laser retroreflector array LRA rover is sent. Alpha particle X-ray spectrometer has been sent. LIBS has been sent. Now LIBS is very interesting. In fact, this time LIBS has given us a very good information that sulfur is present on the lunar surface. Laser induced breakdown spectroscope. Then shape spectropolarimeter of habitable planet Earth. There is no need to mug up these things, but if you have an idea, that's very fine. Rover, the rover that we have sent, that is Pragyan, it consists of alpha particle X-ray spectrometer, and it also has LIBS, laser induced breakdown spectroscope, that is the rover payload. And this rover payload, LIBS, has recently confirmed on August 28 that there is sulfur which is present on the lunar surface through its measurements. And very recently, there have been pictures which have been taken. That means the lander has taken a picture of the rover, and rover, after roving for several meters on moon surface, it has sent a picture of the lander as well. Along with it, it has given us a lot of insights into moon surface and moon regolith. All right. Right. Now, we have launched it to moon's south pole, and I told you we are the first nation. India is first. It's the first country which has reached South Pole. Many countries have tried. For instance, Very recently, Russia had tried, that is Luna 25, Russia's Luna 25 mission, it crashed. But India has been successful. Now, why South Pole? South Pole has been some kind of an enigma to the scientists because South Pole is quite pristine. For billions of years, South Pole, the core areas of South Pole, they have not been touched by sunlight. That is why you must have seen that there is always one face of moon that is seen by us, right, because again the southern side of the south pole, it does not receive any sunlight. For billions of years it has been untouched by sunlight, and for that reason we will get, whenever we analyze the regolith or the lunar soil, then we will get the pristine measurements, pristine parameters for that soil. There is also a belief that there is millions of tons of water in form of ice on moon, and this has been confirmed earlier by India's Chandrayaan orbiter, as well as many other equipments which have been sent by NASA and ESA and the Chinese Space Agency. They have also confirmed that. Apart from that, we can do the regolith analysis. Also, if we use this south pole, which is pure pristine, we can later on jumpstart or move towards the other missions. Today we have reached moon, tomorrow we will reach Mars, right? Again, not as an orbiter, but probably as a lander in future. That's the basic idea. All right. In the meantime, this mission is still running for whatever days the rover will be running. So these 14 days are going to be really exciting, and people are waiting for a lot of scientific information. And Chandrayaan 3, that is the lander in the rover, they have not disappointed. All right. Now, apart from this Chandrayaan, there is one more mission which is going to be launched very, very soon. ISRO in 2023 will be launching the Aditya L1 mission. Now, Aditya L1 mission, questions can emerge on this. What is Aditya L1 mission? What is the significance of Aditya L1 mission? ISRO has recently confirmed the date that Aditya would be launched on September 2nd, 2023. So, before your mains examination itself. I wouldn't expect questions now. Basically, now I think the question paper would be set final. So the current affairs from this period, I wouldn't really expect, or there would be a very low probability of things appearing. But Aditya has been in news for a very long time. Its date has been confirmed on September 2. So questions might appear. What is Aditya L1? What is the meaning of point L1? What is the utility of that particular point? And ultimately, how is it going to help us? How is it going to help India? All right. So let's try to understand Aditya L1. Aditya L1, it is going to be India's first space-based mission where we are going to send a mission specifically to study the sun. Again, this is going to be from a strict perspective, I would say this is going to be second astronomy-based our launch. The first astronomy study mission specifically for astronomy, it was AstroSat. It was not for sun specifically, but this was an astronomy based satellite which was launched in 2015, and not specifically for sun but astronomical studies, dedicated for astronomy. This is going to be second one, where again it is connected to astronomical study itself, astronomy study specifically about sun. What are we going to focus? We are going to focus on studying the sun's external environment. Of course, we cannot go very near to sun. It's physically impossible. So I will be at one particular point away from Earth, about 1.5 million kilometers from Earth, at a particular point called L1. This spacecraft will be placed there, which is going to give you a lot of studies about sun. Again, please remember, this is going to be launched atop the PSL, along with, not atop, I would say, this is going to be launched by the PSLV XL spacecraft. All right. Aditya L1 mission, it is going to study sun's corona. Sun's corona is responsible for giving you visible and infrared radiation. Sun's photosphere, which is responsible for release of X-ray. Sun's chromosphere, which is responsible for the ultraviolet radiation. And apart from that, it is also going to study the coronal mass ejections that come out of sun. The coronal mass ejections, they are responsible for solar particles, solar winds, solar flares, which when we reach upper atmosphere, they can lead to geomagnetic storms. disrupting satellite communication, disrupting the upper atmosphere or upper atmospheric characteristics on Earth. So to study these, we are going to send Aditya L1 mission. Now, Aditya L1 missions, its science objectives according to ISRO are: first, study the upper atmosphere of sun, chromosphere and corona dynamics, study chromospheric and coronal heating, also study the ejections, coronal mass ejections and solar flares. There is going to be in situ observation of solar particles and solar plasma. There is going to be a study of solar corona and heating mechanism. They will also learn about development dynamics and origin of coronal mass ejections. Along with it, there is also an equipment or payload on this to study the magnetic field measurements from solar corona. So these are mission objectives. Now, next question comes, so what is the meaning of this L1 point? Now, L1, it is a point called as Lagrangian point. It is named after French scientist, I would say mathematician Louis Lagrange, when he conducted gravitation based studies. Now you do know that celestial bodies, they have huge gravitational force, gravitational power. Of course, every individual, according to Newton's law of gravitation, every individual or every object attracts another object with gravitational force, but it is perceptible, it can be felt for the celestial bodies because their mass is extremely huge. Because of their huge mass, the gravitational force or gravitational field can be measured, can be encountered. Now, we understand there is a gravitational force or gravitational field of sun, there is a gravitational force of Earth, and according to Louis Lagrange, based on mathematical calculations, he said there will be 5 points, where the gravitational field of sun and gravitational field of Earth, they would be balanced. That means G of sun, that would be balanced more or less equal to G of Earth at these 5 points at L. And these 5 points can be found out along a line drawn between Earth and sun. L1 point, which is in between Earth and sun. L2 point is beyond Earth. Now L3 point is beyond sun, it is behind sun. L4 and L5, now these are most stable Lagrange points. These are most stable Lagrange points. All right. Now, since they are stable Lagrange points, what happens is their utility is quite low for us. Okay, utility is quite low for us because it is an area which is filled with asteroids as of now. So from common sense, what point would be best for studying sun continuously? That would be the L1 point. Now please remember, L1, L2 and L3, they are unstable points. They are unstable points. That means the spacecraft that I send, it is going to hover around this L1 point, and every approximately 23-24 days it needs a course correction to stay stable. So if anybody asks you, sir, what is the meaning of Lagrange point? It is a point where gravitational pull of two large masses precisely equals the centripetal force required for small object to move with them. So the object will move with these, or move along with the gravity of these bodies. It simply needs a small course correction. That means it will be hovering around the point. Now if you want to understand, let's try to get an idea here. See, when we send it, say at the L1 point, it needs a small course correction. It needs a small course correction within this particular range. All right. And when we will launch the Aditya L1 mission, it is going to, first of all, it is going to revolve around the Earth. That means its orbit is going to be raised slowly and steadily, and after one particular point, it would be moved towards the L1 halo orbit, and this is the L1 halo orbit, and around it is simply going to hover. It is simply going to hover around the L1 point, not around sun or Earth, but around that particular point. I simply have to do course correction. That's the basic idea. All right. Now, apart from that, as I told you, L1, L2, L3, L4, L5. There are 5 points. L4, L5. If you draw a line between sun and Earth, simply draw two equilateral triangles of this particular distance. You will get L4, L5 points. These are stable points. Now, L4, L5 points, they are stable. They provide stable orbits, and that is why you will find huge asteroids here. Bigger asteroids like Agamemnon, Achilles, Hector, etc. are found at L4, L5 point, L4, L5 system. So point L1, we are sending Aditya. It is also home to SOHO. SOHO is Solar and Heliospheric Observatory satellite, which is already there. L2 point is a home. L2 point is behind Earth. It is a home to James Webb Telescope. It is a home to Planck Telescope. It is a home to WMAP spacecraft. It is also home to the European Space Agency's Gaia probe. L4 and L5 are rather useless. L3 would also be useless because L3 is beyond Sun. Connecting there, it would become really, really tough, isn't it? Right. So these are the points where I am I'm sending my Aditya L1, and very soon it is going to be launched. Now, along with Aditya, I am sending different payloads. Now, Aditya is a spacecraft on which I am sending 7 payloads, which will be studying the coronal mass ejection and other characteristics of Sun's chromosphere, corona, and other features. And these payloads are being developed by different institutes. Again, if we talk about a payload called VELC, it is being developed at Indian Institute of Astrophysics. Soot, it was recently delivered. This was one of the last payloads which was delivered by the Inter-University for Astronomy and Astrophysics, Pune. Aspects, it has been developed by Physical Research Laboratory, Ahmedabad. The PAPA payload, it has been developed by Physical Laboratory, Vikram Sarabhai Space Center. The Solex and Helios 1 payload are developed at UR Rao Center, Bengaluru. There is no need to remember all these, but it is better to have a small idea or a vague idea about what are the payloads that we are sending. There are some remote sensing payloads and some in situ payloads. These in situ payloads, they will analyze the particles. They will analyze the particles. Very important. All right. So remote sensing payloads are VELC, vision emission line coronagraph. Then solar ultraviolet imaging. Soot helps in ultraviolet. This will help in the visible range. This will help in the X-ray range. 2 payloads for X-ray range. And then there are particle analyzers. There is a plasma analyzer. There is a solar wind particle analyzer. And there is a magnetometer also for assessing the magnetic field. All right. So that's the development that we have achieved till now. All right. Right. So we'll do one thing. We'll wind up the session for today, and we'll continue this space related discussion in the next session, where we'll finish off the space tech, and there the focus would be predominantly on our future missions, some of the important future missions. Along with it, we'll also talk about some important themes or questions that might be asked, or that are very relevant for us from exam perspective. Clear? Right. So again, thank you for watching this video. I'll meet you in the next class. Jai Hind.